I want to talk about Blueprint for Rust backends today. Who am I? I'm Marco. I'm the founder of Mainmatter. We're organizing this today, as they already said before, with the Rust Hamburg meetup and Otto, who are so nice to host us today. Who is Mainmatter? What are we doing? We're a software engineering consultancy. We're focused on web and cloud projects, front end and backend. And we help clients to deliver better results more efficiently and more predictably, as well as to adopt new technologies, right? And one of these technologies that we help clients to adopt is Rust, obviously, right? So what we offer is, in particular around Rust, is a custom development where clients hand over work they don't want to do themselves or they can't do themselves, perhaps. We do training and support. We have a pretty extensive catalog of Rust workshops. So if you want to have a Rust workshop, then please reach out. We also do team reinforcements where our experts sort of join the client's team to work with them for some time on any project that's important to the client. And that really pairs well typically with training and support, right? Do a Rust workshop first for a few days, and then our experts sort of work with the client's team after that for some time to help them sort of put what they learned in the workshop into practice sort of in their project. And then we also do strategic advice, which includes sort of advice on like architectures and sort of like technical transformation, developer tooling process, and so on. And we also organize or like co-organize events like this, and organize a conference you might have heard about, hopefully, which is Gerust. I hope some of you were there. I know you were there, Kai. I hope some others were there as well. And I hope everybody who was not there is going to come next year, October 9 and 10 next year, and we'll be in Paris next year and online. It's a hybrid event, so you can also join remotely, but I would recommend, or like, if you can make it, then join us in Paris. It's going to be nicer. I also brought some stickers from this year out there on the table. So you see, we're quite heavily involved with Rust and the community, and that's because we believe it's great, right? As I think all of you sort of would agree with. And we think it has a lot of potential also in areas where that potential hasn't really been realized yet so much. And we're not the only ones who love Rust, obviously, right? Like all the decision makers at the big corporates love Rust no less than us. All of the big players in the industry are sort of in the process of adopting Rust in quite significant ways. So AWS, who use it for their platform, Google is using it heavily. Microsoft is using it in Windows, I think, and so on, right? And also Rust like flies planes and satellites and so on, because it's obviously a great fit for that as well. So in general, Rust is being used everywhere where sort of previously people used C and C++, right? Like systems programming, operating systems, obviously, embedded stuff, low-level tooling, like JavaScript tooling, you might have heard, is like massively moving over to Rust games, game engines, and so on. But like I said, we are more focused on a different area, which is we are more focused on a different area, which is the web, right? So front end and back ends, Rust obviously more on the back end. And that's not really something where a lot of people used C and C++ before, obviously, right? People use like Ruby, Python, Node, Java, that kind of stuff there, right? But yet we think that Rust has a lot of potential in that area as well, because it gives teams building web and cloud apps access to capabilities that were previously out of reach, right? Like new levels of stability, new levels of performance, new levels of efficiency, and also new levels of sort of long-term maintainability, right? Which is a nightmare with like Ruby, JavaScript, Python, and so on, right? And while the web and cloud space is still relatively young and an evolving area for us, still there's quite some companies that do it already to some extent, right? One of them being Otto, which is sort of its limited use, but we all hope it's going to be growing over the next years, right? But the question is, how do they do it, right? And how does a team that wants to start a backend project in Rust now, essentially, how do they go about doing that project and putting sort of the plan into reality? In general, Rust is ready for the web, right? Like are we web.org is not lying, right? All of the different things you need to be handled in order to build a full backend application are handled. There are crates available for all of that stuff, right? So first of all, obviously there's Tokyo, which is kind of the async runtime and really the main building block for a lot of backend stuff in Rust. Then obviously there is the web frameworks, right? Axum, Actix being the most popular choices. And in general, everything you need to be handled is handled, right? Like HTTP in all versions, WebSockets, TLS, and so on. So you get all of that in Rust. Then kind of below the web framework, you have databases, right? There's mature and well-maintained drivers, sort of at least for the most relevant databases. There is object relational mappers if you want to use one. There are sort of relatively stable options there as well. And there's a number of data stores that are written in Rust themselves, obviously, because Rust is like a pretty obvious use case for those kind of things. And then there's a number of other things you want to be handled when writing a web, like serialization, deserialization, like Surday, obviously hugely popular in the Rust space. Implementations of various messaging formats and crates for like internationalization, templating, and all of that, right? But the point is, all of this is a bit of a draw the rest of the old situation, right? So if you have all the building blocks, but you need to figure out how to put them together and how to like actually build a project that you can also maintain with a group of people, right? But ideally, we would really have something that's on a higher abstraction level, right? So that teams can be focused more on solving the essential complexity of their application versus spending time and losing time figuring out accidental complexity. Like folder structures, like setting up logging and tracing, like figuring out how to organize the data access layer and so on, right? All of these things you don't necessarily, or like if you spend time on that, that's not necessarily valuable in the sense of how it supports your business goals. There are some approaches for that. So there's Loco, there's Rocket, obviously there's Pavex as well. They are all a bit different in terms of their approaches, and we don't necessarily agree with all of the decisions they make, right? Although I have to say we agree with a lot of the stuff that's in Pavex, because that's being written by Luca Palmieri, our like principal Rust consultant and Rust expert at Mainmatter. It's very ambitious and new, and therefore it's not necessarily the perfect choice for everybody, right? It's certainly a great choice for some, but not necessarily for everybody, right? So we thought, let's add another option to this group here, and one that answers sort of the question of how a Rust backend project would look like that's less new and less ambitious than Pavex, and that uses sort of standard crates for the various aspects of the project, and also one that is a bit more optimized for the use case we see for backend projects written in Rust. And that is what we call Gerust. It's our idea for how like a Rust backend sort of project would be structured, that uses sort of standard crates already available in the ecosystem and sort of assembles them sort of in a very particular way, right? It is based on Axum and SQLX. We could have used Actix here, and there's really no right or wrong answer whether Axum or Actix. They're both great. What speaks for Axum maybe is that it's sort of part of the Tokyo project, which might be a positive signal for like long-term sustainability and maintenance. SQLX is relatively easy to use and is pretty stable. And we deliberately decided against using an object relational mapper, as that typically introduces a lot of accidental complexity into a project again, right? So we would rather have a bit more lines of code that are simpler than having fewer lines of code, but having a ton of additional complexity added to the project. One important aspect of Gerust also is that it is not a framework. It's a project generator and maintenance tool, right? But there's no runtime dependency on Gerust. So all of the code that it generates sort of remains under your control without any additional sort of dependencies on any parts of Gerust. Obviously, you have dependencies on Axum and SQLX and so on, but you have dependencies that are pretty established in the ecosystem already, and that you're more likely to trust, right? Because all of you should maybe not trust a framework that I'm announcing here that's like 0.0 point something, right? I'm not production ready. So that might change in the future, but for now, so if it's purely something that generates code that you maintain versus something sort of that you're locked into, essentially. Still, while being a project generator, it handles a bunch of sort of the accidental complexity of Rust backend projects, so you don't have to, as I said before, right? For example, it structures projects into separate crates with separate concerns using Cargo Workspace. It establishes a clear folder structure that makes very clear sort of what goes where. And it comes with generators that create sort of elements of a project, like a controller, an entity, and so on, right? And I think while folder structure seems relatively trivial, I think the importance of it is easy to underestimate, because having a clear folder structure where it's really clear what goes where makes it much easier for new people to join and contribute to a project. And it also helps with long-term maintenance, because it avoids a situation where you have a huge mess of stuff and you can never figure out what's where, right? While we decided against an object relational mapper, as I said before, sort of we still suggest sort of a set of standard patterns for the data layer. And Gerust comes with a mechanism for testing your application that makes sure that all tests are separate from each other, while still sort of ensuring simplicity when writing tests and maximum performance. So I hope all of that sounds nice, but words like only go so far. Now it's time for a demo, right? And the demo is going to be, we will be building a really, really, really simple task management app with a REST interface, right? The classic example. And now I need to figure out my screen sharing. Okay, great, that works. So we will start by generating a new project, and I think we call it Gerust Hamburg demo. And I just need to put out my notes here. Great. So we generate a new project, and it's generating. And this is what we have. Just a second. So we have a new project. Is it large enough, or shall I make it larger? Okay, great. So we do have a new project. Like I said, it's a workspace. We have a bunch of crates, like CLI, config, DB, web macros, and the default project is the web project. So let's go through them one by one. First of all, the web. We have like web source, sort of standard cargo folder structure. The lib file is sort of the main file of the project, where in the run function, we read the environment, we read the configuration, we set up the application state, we set up the routes, and then we start the server, essentially, right? The application state is in state RS, not surprisingly, and it defines the app state, which so by default has the database pool, like the connection to the database we want to use. The routes file defines the application's routes. Here we don't have any routes yet, but so we'll be adding some later on. And then we have a controllers directory that is empty for now, and we have a middleware's directory that's also empty for now, but that's obviously where controllers and middlewares go. Then we have the DB crate with entities folder. We don't have any entities yet, but that's where the entity definitions and related code is going to go later. We have test helpers. We are not going into detail around those, but we have documentation for them. And then we have a migrations folder where the migrations are going to go, obviously, right? Then the next thing is the config crate, which contains the struct that keeps our application configuration. As you see, it contains database configuration, which is basically sort of the database URL, right? Use this database. And server configuration is basically what interface to bind to, right? And then we have environments folders, or we have an app toml, and then environment specific files where sort of you can override sort of settings in the app toml sort of based on the current environment you're in. It's also empty by default, but you would be adding your own stuff there. Then let me close some things. Then we have the CLI crate. So this is essentially the generator that I talked about before, right? That allows you to generate, for example, new controllers, new entities, new entity test helpers. We're not going into detail what those are here because it would be a bit too long, new middlewares and so on, right? And this is part of the project because, as I said before, we don't want Rust to be a dependency. We just want Rust for now, at least, to purely be a project generator, right? So all of the code that you need to sort of run and maintain your project is part of the repository. And so are the blueprints for the controllers and so on, right? And then we have the DB binary. We're not looking into the code here, but the DB binary is essentially for running migrations and setting up databases and so on. Right, and now I want to briefly remove this again and clone an example that I made before, which is essentially what I just showed you with a few fixes that I made, and we're not going to detail what the fixes are. So one thing that Gerust created out of the box as well is a Docker configuration with a development and test database. So the first thing that we want to do is we want to start up the containers. So we have that running in the background. Let's open a new tab here. And then when we want to write a task management application, the first thing that we need, of course, is a task entity, right? That represents the tasks. So we can generate that with the generator that I showed before. First of all, let's sorry, it's not Gerust. That's so the this is a binary in the application, so we're not using Gerust, we're using Cargo, obviously, right? So we can see what the available things that we can generate are after it has compiled for the first time, of course, which is going to take a second, and then it's going to show us what we can generate. Almost done. Right. So here we see we can generate a middleware, controller test, migration, entity, and so on, right? Like a bunch of things. But now we want to create an entity. Generate entity task. and that's gonna create an entity task. So obviously, because of the folder structure, let me close the other things here. Obviously, the entity was created in source entities because that's obviously where the entities go, right? Right, and I'm sorry, this is a bit annoying because Rust Analyzer is, I don't know, doing some stuff that doesn't quite work. But this is sort of an entity sort of that's already sort of pre-populated with kind of example data, right? We have the entity struct here, right? It's like a standard Rust struct with an ID or with a UUID ID and a name, but we want to use a description here, right? Then the next thing that it generated is a change set. So the data layer in Gerust is inspired, I want to say, by Ecto from Elixir. I don't know whether you guys know that. That's yeah, sort of Elixir's ORM, but it's not really active model like. It's a bit different. And they work with change sets where sort of the change set is a thing that, for example, you're validating and then you're passing to a create function, for example, right? And then sort of if it's valid, sort of it's going to be like used to read the data from, pass to the database, and then it's going to return an entity. In our case, there would be a task struct, right? So we need to be changing name to description here as well. And we want to change the faker to this, just so it's nice. And I also need to change this. We don't need to go into detail why I do this now, but the change sets sort of come pre-configured, at least when the test helpers feature flag is sort of on, which is going to be the case when we run the tests in the web crate later on. So if that is on, we sort of use the fake crate here to make it so that you can easily create dummy data for the tests, right? And this essentially just means when faking a task change set for the description, use a sentence between 3 and 8 words, right? And that's going to be realistic test data then. Let me see my notes here so I don't forget anything. Right. So the next thing that we can do is we can remove all of the to-dos here because we actually want to use all of these functions. Let me do this. So we do it a bit faster. Whoops. All right. And then we want to replace name with description. Did I type that correct? Description. It's one of the words that are really hard to type. So let's replace all the name with description. So right. So the second thing that we see about the data access pattern here is that instead of an ORM, sort of we said, okay, we would rather have a bunch of simple or a bunch of more simple lines of code or simple functions than an object relational mapper, right? So we have a load all, a load by ID function. We have a create function which takes a change set. Like I said before, it validates that. If it's valid, it inserts a record into the database and then returns a task, right? With the data from the change set applied to the task, and the ID is auto-generated by the database, and so on, right? So we always have these sort of standard functions instead of like a magical or setup. Right, so now we should be able to build this. So we'll have a few builds during the talk, but I think they should be fast enough to make it bearable for you. Right, so we've built, but it doesn't succeed because of SQLX sort of compile time query checking that we're doing, right? And while the database is running, we have not created the table that we need sort of to back the entity, obviously, right? So the next thing that we do is we generate a migration. And that is like created with a timestamp. The migrations are ordered and so on, which is like pretty standard and sort of what other frameworks do as well. And I have prepared the SQL statement so I don't end up making 1,000 typos here and you all wait forever. So we just create a task table with an ID that sort of there's going to be assigned by the database, right? And then description, voucher, and so on. So now we can use the DB binary to migrate the database. Oh. Let me. So this, I have a bunch of other stuff, right? Ignore this. We're gonna reset all this. So we are gonna start the Docker containers again, and now we should be able to migrate the database, right? And now we can build the project, and it should succeed, right? So now we have a task entity and all of the functions that we need to load tasks and like save tasks to the database and so on, right? And now I want to sort of reset to a known working version, so we don't end up with a bunch of problems, right? So this is sort of the same code that we just saw, right? We have the task entity and the migration and all of the functions that we need. The next thing that we want to do is we want to generate the REST interface to be able to read tasks from the database or like from the application, which reads them from the database, and then we want to see them as JSON via the HTTP, essentially, right? So what do we need for that is we need a controller, obviously, right? So we can cargo generate. In this case, we want to generate a CRUD controller. So CRUD controller comes with sort of the typical CRUD functions already built in. So we'll just have to customize that a bit. CRUD controller tasks. So there we have our CRUD controller. You see it already created a test for the controller as well, because obviously we want to enforce good practice and want people to have tests for the controllers that they generate. So let's close the DB crate and look at the web crate. So we have the tasks controller here, and this case we only care about reading all tasks and creating a new one, so we're going to remove all of the other ones, and then we will sort of look at the read all function first, which is going to return all of the tasks that are in the database, right? That's not necessarily a realistic example, because if you have a million tasks, you don't like want to return them all and so on, but for the sake of simplicity, this is fine, right? So we need to remove like the example stuff, and we now have a pretty straightforward function that uses the load all function that we saw in the DB crate. So in the data access layer, it passes the DB pool from the app state, and then some info here, and then it just returns all of the tasks as JSON, right? Pretty straightforward, but still very clear separation of concerns. So if you have the database stuff in a separate crate, and this is just using an interface to load the tasks, and you could change all of the data loading without having to change the web interface as well, of course. So just making sure I didn't forget anything here. So which would prevent this from working. No, this should be fine. So next step is we need to route the the function. So we need to use create controllers tasks here. And then we need the routing get, because there's going to be get request obviously, and then we can route tasks to get task load all, right? And just checking my notes again. This should work, but probably I made some mistake somewhere. So we can ignore the warnings here. This is essentially just all about sort of the stuff that we're not using from sort of the pre-generated things. And so what's the issue here? Can I find it out? Oh, why can I not find that? Let me just quickly try and figure it out. We have, so I can't find this, right? Ah, right, it's read all. Yes, great, thank you. And now we can curl and get a response. So we're just curling /tasks and we get a response. Obviously the database is empty, so we don't get any tasks, but we can put something in the database here. Just present Gerust in Hamburg. All right. Oh, whoops. No, it's there. And then if we call again, then we get our first task, right? Right. So the next step is obviously we want to have a test for that. And as we saw before, the tests were pre-generated already. So we can go to tests, API tasks, test, and look at sort of what was generated before, right? And what we wanna, I just need to fix something here. You can ignore this again. Like I said, this is not a 1.0 version, right? So we need to fix that. We want to ignore the create tests because we haven't done the creation yet, right? And we will be focusing on the test read all, and we'll delete all other tests because we don't care about them for now. Right, so then we can sort of uncomment this, and this is mostly going to be fine. But we can have a look at what this actually does. So you see, we don't use the standard test macro from Axum or from Tokyo. We use db test, and we get a db test context struct passed into the test, right? That is made possible via the macros crate. So we do have our own test macro here that sort of sets up the application with a database that is sort of specific and unique for that test. And it also sort of makes it so that the function is called with a context object, and the context object has a database connection to the same database. So you can pre-populate the same database that the application is going to be using when you make the request in the test, and then the database is going to be destroyed after the test, right? So that's all built in. So that's one thing where you don't have to figure out the accidental complexity. What we do here is we create a change set. As I said before, we can just use faker because of that automatic fake data setup. So we create change set, and then we use the create function from the DB create to sort of insert that into the database. We make a request. So we have some convenience functions here on the application that make writing tests easier, and then we can assert we get a positive response, and then we can assert that the task that is being returned is the task that we inserted into the database before, right? Because we're using the same database, and no other test is going to use the same database as well, because it's a database that is unique for that single test. And this should work. We'll see. Bunch of warnings, but like I said, oops, we don't care. Right. And it does not work because the tasks table does not exist, right? We migrated the database, but we migrated the development database. So now we do have to migrate the test database as well, obviously. So cargo db migrate the test. That's going to migrate the test database, and now the test should work, right? And we didn't do a lot of stuff, right? We sort of like generated a bunch of code, sort of filled in our sort of specific, like application specific things into the right places, and everything else was sort of handled by Gerust. Right. So now we are going to sort of check a sort of known to be good version. I'm not doing it clean here because then so the rebuild takes longer, obviously. I'm just sort of resetting this so to reduce the risk of sort of making mistakes, and then we are blocked during the demo. So this is kind of the same stuff now that we just wrote without any potential mistakes that I just made and we didn't realize. So the last step we want to make here is we want to make it so that it can also create a task via the interface, right? By the web applications interface. And as we saw before, we do already have the create function in the controller that was created as part of the CRUD creation, right? There were also like read one and delete and update and so on, but we delete them for the sake of simplicity. So this is the create function now. We can sort of uncomment all that because the code as it has been created is already what we need, right? So we do have a function here that receives a change set sort of as JSON data, right? As part of the request payload. We pass the change set into the create function of the DB create that we saw before, which is going to validate the change set, right? If it's valid, it's going to sort of apply it and then return a task. And if that happens, we respond with status 201 and the task and a JSON representation of the task. Right. The only thing that we need to do still is we need to route that, right? Because we only routed the read all function before. So this is going to be essentially the same. It's also tasks, but it's going to be post in this case and create. And now this should already work. I prepared a call statement here with some test data before. So if we read all the tasks, we get the one that we put into the database manually. Then we can create a task, right? It's just like authorization you can ignore. It's from a different example, actually, where we had a middleware for authorization. So I should have deleted that. But essentially what we're doing, we are posting JSON here, like a description, right? And this should have worked. And we see sort of the task has been created. If we, I'm not sure whether this works. If we do this is invalid, then it should, right. It responds with photo 2 and an error message. The last thing to do now is to make sure we have tests for that, because as I said before, we want to have tests for everything that we're doing, obviously. So we can enable the tests again. So if you're not sure what enabling means by adding this, so if you don't have this attribute, then the test runner will essentially just ignore the functions. It's just functions that mean nothing for the test runner, right? So that's an easy way to so skip a test in Rust. We can uncomment all that, and then we can look at what we're doing here, and the standard sort of crust controller test should already be doing what we need here. So we want to test first that sort of an invalid change set sort of leads to a 4-to-2 response, as we just saw on the command line, right? So we pass a change set with an empty description, which is not gonna sort of meet the requirement of sort of the description having to be at least 1 character long, obviously, right? And then we post that and assert that the response is 4-to-2, and the same here with a valid change set. So we just use whatever we get from the faker, and this works as well. And I just see like there's one extra error here, which I thought I fixed before. So we need to go here and copy something from a pull request I made earlier today on the train, but somehow did not. No, I can't find it, I think. Let's do differently. So this needs to be slightly different. Sorry, this is not as it was planned, but this should be here. Right, so we need this. So ignore what I'm doing in this, like what should actually be working already. And then we should be able to cover test. And no, it does not work because I made another mistake. Probably where's the 49? Right, so this is context, right? And this is also a wait unwrap. And this should work. Oh, and this is a reference. Now it actually works, right? So all of that stuff that it just did will, of course, in the next release, it will all be fixed, and you won't have to do any of that yourself, obviously, right? So that is a very quick walkthrough through Gerust. And to close, I have a few remaining slides now. So that's what we just saw, is sort of how you build a very simple sort of CRUD interface to stuff you have in the database in Gerust. And we didn't do a lot of things. We didn't figure out how to sort of isolate tests. We just used sort of what's there. We didn't figure out tracing and where to put stuff and all of that, right? Yet while Gerust covers a bunch of things already, as we saw, and it has support for more stuff that we didn't look into, like entity test helpers and middlewares and so on. Obviously, this is still pretty early, as you just saw in the demo, and there's a bunch of stuff that we still need to be doing, right? So first of all, and that's something that we work on right now, is we need to finish the documentation and the tutorial. The second thing that we need to be doing and that we're working on is we need to figure out the deployment story. At least we should have guidance on sort of on how you deploy in the most common scenarios, the most common environments, which also includes stuff like how do I run migrations in my production environment through deployment and so on. We need to complete the data access layer approach that we have. It's relatively simple, as you saw, but we're missing support for some things that should ideally be handled out of the box in some form. For example, relationships between entities and some kind of pagination, because any read-all function in the data access layer is obviously more or less an anti-pattern. And we need to figure out a solution for background jobs, because you are very likely to have some kind of background jobs in any sort of production environment. After those, we have some ideas for the future already, but this is sort of more long term. It might be nice to have support for other databases than just Postgres. It might be nice to have some sort of like out of the box open API integration thing, which is going to be pretty helpful for the typical backend project. And ideally, we would like to have some mechanism for upgrading projects sort of as we release new versions of Gerust, right? Because obviously, like right now, sort of you have like you generate your project, and then when we release a new version with a new blueprint, sort of there's no clear way to sort of migrate your code to that, right? But I think we can probably figure out something that is at least makes it easier, right? But still, we're inviting everybody to check out the framework and give us feedback, because we think there is like place in the ecosystem or room in the ecosystem for a framework, or like I said, project generator for now, for a way to build Rust backend sort of that is optimized for developer experience and optimized for long-term maintainability, which is typically, at least the latter, is typically a reason why you pick Rust in the first place, without just blindly repeating what we see in other frameworks, right, in other languages. And yeah, we hope that Gerust can be sort of a tool for the community to sort of figure out the solution to those questions together. And that's it already. Thanks.
Any questions? Okay.
Why is it not called Gerust?
Because I don't know whether you can have an Ü, like an umlaut in crate names. You can definitely not have an umlaut in GitHub project names, because when I did the very first sort of experimentation for that, I thought I'm writing a REST server in Rust, so I should call it Rust, but that doesn't work on GitHub.
Yeah, I guess so. But it would have been funny, like a German.
It would have been funny, but I mean, this is kind of funny. It's a play obviously on Gerust and Rust, right? And I have to say the idea wasn't mine or ours. It was Florian Gilcher's idea, and he sort of donated the idea to us and allowed us to use it.
Thank you.
Thank you, Marco, for this great talk. And I would like to kind of ask a small two-part question. By the way, new in Rust community, don't shoot me if I say something stupid, okay? So what we see here is something great, which is something like, with lack of better words, something like what other programming languages in their ecosystem already have. And Rust is still not having it. And we're all waiting for this to happen. Yep. Like Spring for Java, like Laravel for PHP, or I'm not comparing your code here to those guys.
Yeah.
I'm just saying, sure. That's the idea, right? To have like this one dependency at the end to rule them all, and then we can just go in our development node, write Rust code, have fun, right? Is this correct?
I mean, more or less. I wouldn't say the goal is sort of to have one dependency, one framework to rule them all. I think there can certainly be like 2-3 options or whatever, right? But sort of you need, if you're a team that, I don't know, is doing Rails now, that's doing Phoenix, and at least, any kind of Java framework, whatever, and you want to go to Rust, sort of you need something that you can build on, right? Because I mean, you don't want to spend a lot of time figuring out these things yourself, or maybe you can't, right? Maybe you're not allowed to, start from the bottom up, right? Because it obviously takes a lot of time and so on. But yeah, I mean, the idea though is to not just copy what other frameworks have, right? The idea is more to look at why do we typically pick Rust in the first place for backend projects? And then let's build a framework that's optimized for these scenarios, right? So for example, we have no way to render in HTML because I personally don't think that's a typical use case for Rust. Right? I think Rust is more for, REST APIs, where a microservice that, like gets stuff over HTTP and does things and so on, right? I can't really see the use case for rendering HTML because, I don't know, we are big fans of Svelte and SvelteKit, for example, right? I would probably choose SvelteKit for building a UI, but then behind that, I want to have something that has stability and performance and so on of Rust, right? So, yeah, that's why we did not just copy Rails, for example, right? I think Rails is great, but I think Rails is for a very different use case than the typical use case you would be choosing Rust for.
And that's the second part of my question, exactly. Exactly in this zone we want to stay. So we have Rust on one side, like one extreme is like the perfect case for Rust, like mission critical systems, memory efficient systems where garbage collection is not allowed, right? These kind of systems. So that's like perfect place for us. And then when we go away from there and we go to Ruby and stuff like and Rails. So that's the opposite spectrum. So now you're going away, I would say, with this, we're going away a bit from the ideal Rust place. And I would like to know from your experience at Mainmatter, your clients or your internal things that you built with Rust, what is the technology that you are replacing with this stack that you have built? What is the thing that was a problem and you decided to go to Rust way?
Yeah. I mean, first of all, I would say I don't think we're going away sort of from, using Rust for building super optimized, very stable and so on applications, right? I think any kind of like handcrafted ad hoc framework would probably look pretty similar to this anyway. I think the place for us in sort of cloud backend apps and so on is I think you're typically picking it for its performance and stability, obviously, right? For, I don't know, you have sort of a bunch of microservices and some sort of proxy in front of that, right? That sends sort of requests from like the internet sort of to
the gateway, yes.
Right, to like many of the microservices, sort of based on the requests and so. So I think that's a typical use case for us. Or I don't know, a microservice that you have already, but you have massive stability or performance problems, right? That's what you're replacing. I think once you're past that point, sort of these cases are typically sort of the first projects done in Rust in a bigger company, right? Because there you can justify the investment for a team having to learn Rust and the team being potentially a bit slower with Rust for some time compared to like what they used before Java. So I think once you're past that point, sort of you can replace other things as well, right? Where sort of you don't necessarily, or where it would be hard to argue for making an additional investment for us because the additional investment is going to be smaller and smaller and smaller and smaller. So you're really comparing sort of only the sort of advantages of Rust versus the advantages of Java, whatever. And then you can always say, okay, this is going to be more stable, it's going to be more efficient, it's going to be faster. And I think the long-term maintainability aspect is going to get more relevant over time as well, because like of the strong type system, right? It's just much easier to reason about the Rust code base. And if you're making a mistake, the compiler's going to let you know, obviously, right? So I think right now the use case for us, or the reasons for picking Rust, are mainly sort of solving performance problems, solving stability problems, but over time sort of I think we can diversify more into other areas as well.
Thank you, Marco.
Thanks.